Greetings, passengers. This is your vessel's onboard guide, Soul Voice Unit 7. Please ensure your harness is secure, refreshments are within reach, and eyes are ready for the sights of an ancient system. My task, to inform, entertain, and most importantly, not crash the ship. You just sit back, breathe easy, and enjoy the ride. Ahead.
Mercury, the smallest planet in Sol and the one most often mistaken for the Sun's personal doormat. For billions of years, it's been baked by solar radiation on one side, while the other side plunged into darkness. Early human astronomers thought it was two different stars, naming them Hermes in the morning and Apollo at night, until they realized it was the same lonely rock. Mercury's surface tells a violent story. A crust battered by asteroids, scarred by the ancient Callisto Basin, one of the largest impact craters in the solar system. Its days are long, 59 Earth days to spin once, yet it zips around the Sun in just 88 days. And despite being so close to the Sun, water ice hides in shadowed craters at its poles, a cosmic reminder that even here, in the furnace, there are pockets of cold. For early spacefaring humans, Mercury was mostly a curiosity. But later in the 23rd century, orbital platforms harvested solar energy here on a scale Earth could never dream of, turning Mercury into the first true solar farm of humanity. Today, we cruise by for its history, its extremes, and the sheer beauty of watching the sun rise 3 times in one Mercurian day. Approaching Venus, the second planet from the Sun and often called Earth's sister, though the resemblance ends at size and gravity. Beneath its soft golden clouds lies a nightmare world, temperatures hot enough to melt lead, atmospheric pressure crushing like a mile of ocean, and a sky thick with carbon dioxide and sulfuric acid. For centuries, humans imagined Venus as a tropical paradise, lush jungles hidden beneath the clouds. Those dreams died in the 20th century when the first probes revealed a hellish wasteland. The surface bakes at nearly 900 degrees Fahrenheit, with slow, choking winds at ground level and hurricane-force gales high above. A day here lasts longer than its year, 243 Earth days to spin once, but only 225 to orbit the Sun. Venus may have once had oceans and a temperate climate until a runaway greenhouse effect transformed it into the inferno we see today. That history made it both a warning and a fascination for early spacefaring civilizations. Floating research stations were built high in the clouds, where the temperatures and pressures are almost Earth-like, drifting above the deadly surface far below. As we pass, the planet glows like a jewel in the sunlight, beautiful, distant, and quietly hostile. A reminder that not every neighbor in Sol is a friendly one. Approaching Earth, the cradle of humanity, and the only world we know to have nurtured life. From here, its oceans glimmer deep blue, the continents swirl with greens and browns, and clouds trace white patterns across the curve of the globe. For billions of years, it was a silent rock under a young sun, until chemistry became biology and biology became civilization. Every culture, language, and invention began here. It was from Earth's surface that humanity first looked up and wondered, then built the tools to leave. Its magnetic field shields life from cosmic radiation, its atmosphere breathes oxygen into every lung, and its tilted axis gives rise to seasons, cycles that shaped agriculture, migration, and the rhythm of human history. But Earth's story was not without turmoil. Climate shifts, extinctions, and the scars of industry forced humanity to evolve not just biologically, but technologically. By the 22nd century, restoration projects had healed much of the damage, and orbital habitats, lunar bases, and Martian colonies all looked back to this blue sphere as home. From orbit, you can see the lights of cities stretching like constellations across the night side. They are the pulse of the species that once walked only its plains and now sails among the stars. Even on a grand cruise through Sol, this stop is a reminder. Every journey, no matter how far, begins here. Approaching Luna, Earth's solitary natural satellite, and humanity's first step beyond home. Its battered grey face is marked by billions of years of impacts, the dark plains of ancient lava flows called Rhea, contrasting with the bright, cratered highlands. From here, it has pulled at Earth with invisible fingers, shaping tides and subtly slowing our planet's spin. For most of human history, the moon was a distant mystery, a glowing companion in the night sky that inspired myths, calendars, and poetry. Then, in the late 20th century, humans set foot here for the first time, leaving footprints and flags in the dust. That moment became a symbol of possibility, proof that the heavens were within reach. In the centuries that followed, Luna became far more than a milestone. Mining outposts tapped into its regolith for resources, and domed cities rose in its craters, shielded from radiation. The moon's location made it the perfect waypoint, halfway between Earth and the rest of the solar system. Its low-gravity ideal for launching deep space missions. From up close, you can see the Earth hanging in the black sky, vibrant and alive against the moon's stark, silent surface. It is both a neighbor and a witness, watching every chapter of humanity's story, from its first campfires to the very cruise you're on now. Approaching Mars, once the dusty red planet, now a world reborn. For most of its history, Mars was a frozen desert under a thin, unbreathable sky, its surface carved by ancient rivers long gone dry. Early probes found the evidence: dried lake beds, winding valleys, and ice locked away at the poles, proof it once knew water. The dream of terraforming began long before it was possible. By the 22nd century, vast orbital mirrors warmed the surface, releasing carbon dioxide from the regolith and thickening the atmosphere. Genetically engineered microbes spread across the planet, darkening the poles and trapping more heat. As the air pressure rose, liquid water returned, pooling into seas that now glisten where impact craters once stood empty. Today, Mars wears a patchwork of colors: verdant green valleys, rust-red highlands, and deep blue oceans under skies tinted pale gold. The once barren plains now grow crops to feed millions, while sprawling cities stand along the shores of the Hellas Sea and the Valles Marineris Basin. Gravity here is still light, the sunsets still tinged with blue, but the air is breathable and the seasons familiar. From orbit, it's hard to imagine the centuries of work that went into this transformation. Mars is no longer just a destination for explorers. It is a thriving world, humanity's first great act of planetary engineering, and a second home among the stars. Approaching Jupiter, the colossus of the solar system. 11 times wider than Earth, this gas giant dominates its region of space, its swirling bands of clouds and storms visible even from millions of miles away. The most famous of these is the Great Red Spot, a hurricane larger than our entire planet that has raged for centuries, though it has slowly begun to shrink in recent centuries. Jupiter is a world without a solid surface. Its upper atmosphere is a churning mix of hydrogen, helium, ammonia, and water vapor, with lightning storms that dwarf anything on Earth. Descend far enough, and the pressures become so immense that hydrogen turns into a metallic fluid, creating Jupiter's powerful magnetic field, one of the strongest in the solar system. Its influence is more than just visual. Jupiter's gravity has acted as both a guardian and a menace to the inner planets, deflecting some asteroids away while flinging others inward. Its dozens of moons form a miniature solar system of their own, from volcanic Io to the icy oceans of Europa, from massive Ganymede to cratered Callisto. For humanity, Jupiter became a hub of exploration and research. Orbital stations harvest helium-3 from its upper atmosphere, while bases on its moons serve as launch points for missions deeper into the outer system. As we pass, the planet's storms roll endlessly below us, a living, breathing canvas of chaos and beauty on a scale no other world can match. Approaching Io, the most volcanic world in the solar system, and one of Jupiter's 4 great Galilean moons. From orbit, its surface is a chaotic patchwork of yellow, orange, red, and white, sulfur and frozen gases sculpted by relentless geological fury. Mountains taller than Everest rise here, only to crumble under their own weight as the crust shifts and reshapes. Io's restless nature comes from a constant gravitational tug of war. Jupiter's immense pull, combined with the influence of Europa and Ganymede, kneads Io's interior like dough, generating enough heat to melt rock into magma. Over 400 active volcanoes spew plumes hundreds of kilometers high, coating the landscape in fresh deposits of sulfur and ash. For early explorers, Io was a nightmare to land on. Unstable, unpredictable, and bathed in intense radiation from Jupiter's magnetosphere. But its constant activity made it a scientific treasure, offering a glimpse into volcanic processes far beyond Earth. Later, shielded research stations were built into its mountainsides, where scientists could study eruptions in real time, the sky lit with glowing fountains of molten rock. From here, Io is a living world, constantly remaking itself. No crater lasts long before being buried in new flows. No mountain remains untouched by the planet's inner rage. It is as hostile as it is mesmerizing, a reminder that not all beauty in the solar system comes from stillness. Approaching Europa, Jupiter's ice-bound enigma. At first glance, it's a smooth, pale moon, its surface crisscrossed with long, reddish-brown fractures like veins in marble. Unlike crater-pocked worlds, Europa's face is young and constantly renewed, its icy shell shifting and cracking as something stirs beneath. That something is an ocean, Vast, global, and deeper than any on Earth, kept liquid by the same tidal forces that keep Io's volcanoes erupting. Beneath miles of ice, that ocean is warmed from below, creating conditions scientists long suspected could harbor life. Early 21st century probes found tantalizing hints, plumes of water vapor erupting through the ice, chemical traces that suggested a rich, salty sea. In the centuries that followed, Europa became the most important site for extraterrestrial biology. Robotic submersibles dropped through melted shafts in the ice sent back images of strange bioluminescent forms drifting in the deep. The discovery of native life here, however simple, proved that Earth was not alone. Later, human research outposts were built along the fissures, where the ice is thinnest and the oceans most accessible. From orbit, Europa glows softly in Jupiter's reflected light, serene and beautiful. But just beneath that quiet surface lies a hidden alien sea, one of the most promising cradles for life in all of Sol. Approaching Ganymede, the largest moon in the solar system, even bigger than Mercury. From here, its mottled surface shows a mix of bright, grooved terrain and darker, older regions scarred by craters. Its icy crust hides a complex interior, with layers of rock and ocean stacked like the pages of a planet-sized book. Ganymede is unique among moons. It has its own magnetic field, a rare feature in the solar system. This field carves miniature auroras into its thin atmosphere, shimmering ribbons of light that dance in Jupiter's shadow. Beneath the surface lies a vast saltwater ocean, likely containing more water than all of Earth's seas combined, locked beneath hundreds of kilometers of ice and rock. For early explorers, Ganymede was a natural choice for settlement. Its size offers lower radiation levels than its sister moons, and its abundance of water ice made it ideal for sustaining life. Over the centuries, it became the outer system's largest human colony, with sprawling domed cities and underground transit lines stretching across its icy plains. From here, cargo fleets and passenger liners set out deeper into the Jovian system and beyond. From orbit, Ganymede looks calm and quiet, but it is a crossroads, a place where science, industry, and human ambition meet on the largest moon in Sol. Approaching Callisto, the outermost of Jupiter's major moons, and a world that wears its history on its face. Its surface is ancient, older than any other solid ground in the solar system, densely packed with craters that have remained untouched for billions of years. From here, the scars of impacts form bright rings and dark basins, each one a frozen chapter in the moon's long story. Callisto's distance from Jupiter keeps it beyond the worst of the giant's deadly radiation, making it far more hospitable for long-term human presence than its inner siblings. Beneath its icy crust lies a salty subsurface ocean, though far deeper and harder to reach than Europa's. Its stability and safety made it the first major hub for permanent habitation in the Jovian system. By the 23rd century, vast surface domes and buried habitats dotted the moon's plains, linked by maglev lines stretching between craters. Callisto became a thriving trade port for ships traveling between the asteroid belt and the outer planets, its low gravity perfect for launching heavy cargo into deep space. From orbit, Callisto is a portrait of time itself, unchanging, weatherless and silent, yet playing a vital role in the expansion of human civilization across Sol. Here, the past and the future meet on a world that has seen nearly everything and endured it all. Approaching Saturn, the jewel of the solar system. Even from a distance, its rings blaze with reflected sunlight, a vast halo made of countless shards of ice and rock, each one tracing a path around the planet. The sheer scale of the rings defies expectation. If Saturn were the size of a basketball, the rings would stretch almost a mile across. Beneath that beauty lies a giant of storms and gas. Saturn's atmosphere is a tapestry of soft yellows and golds, with cloud bands drifting around the globe. Near its poles, immense hexagonal jet streams churn endlessly, a geometric wonder first discovered in the 20th century and still mesmerizing today. Like Jupiter, Saturn has no solid surface. Descend far enough and you'd be crushed long before touching any kind of ground. Its moons tell stories of their own. Titan, with its thick orange atmosphere and methane seas. Enceladus, an icy world spraying plumes from a hidden ocean. Dozens more, each unique. For humanity, Saturn became both a scientific treasure and a resource frontier. The helium-3 in its upper atmosphere was harvested for fusion, while its moons became outposts for deep space exploration. From here, Saturn is breathtaking, a serene giant crowned in rings that are both ancient and ever-changing. A reminder that in the cold outer reaches of Sol, beauty can exist on a truly cosmic scale. Approaching Enceladus, one of Saturn's most remarkable moons, small enough to fit within the borders of a single large country on Earth, yet hiding an ocean that could rival our own in mystery. Its surface is a dazzling white, the most reflective in the solar system, made of fresh ice that constantly renews itself. Along its southern pole, great fissures known as tiger stripes split the crust, venting towering plumes of water vapor, ice crystals, and organic compounds into space. These geysers feed Saturn's E-ring, scattering a trail of frozen particles far beyond the moon's orbit. Beneath those cracks lies a warm global ocean kept liquid by tidal heating, the gravitational push and pull of Saturn flexing Enceladus's interior. When probes first flew through the plumes, they detected the building blocks of life, sparking centuries of exploration. Robotic subs eventually dove into its subsurface sea, sending back images of hydrothermal vents on the ocean floor, towering mineral chimneys surrounded by alien organisms. That discovery made Enceladus not just a scientific curiosity, but a second cradle of life in the solar system. From orbit, it appears quiet and frozen, but every jet of vapor tells a deeper story, one of heat, water, and life hidden beneath an icy shell in the cold shadow of Saturn. Approaching Tethys, one of Saturn's mid-sized moons, a pale, icy sphere that looks as if it's been carved from frozen marble. Its surface is ancient and heavily cratered, a testament to billions of years without geological renewal. The most striking feature is Odysseus, a massive impact crater that spans nearly 2/5 of the moon's diameter, its walls rising like frozen cliffs above the plains. Stretching across the other hemisphere is Ithaca Chasma, a canyon system over 1,000 miles long, nearly the entire circumference of Tethys. Formed when the moon's interior froze and expanded, it is a scar from a time when Tethys was geologically active, long before it became the quiet world we see today. Though lacking an atmosphere and too small to hold an ocean like Enceladus, Tethys still played a role in human expansion into the Saturnian system. Its low gravity and abundant water ice made it a convenient fueling station where orbiting refineries turned ice into propellant for deep space vessels. From orbit, Tethys gleams softly in the sunlight, its great crater and winding chasm like ancient battle scars, silent reminders of a violent past in a now still and frozen world. Approaching Dione, another of Saturn's mid-sized moons, and a world of quiet beauty wrapped in ice. From a distance, its surface gleams with a soft grey-white tone, marked by dark impact basins and crisscrossed with bright icy cliffs. These cliffs, actually enormous ice walls hundreds of meters high, are the result of fractures in the crust, where clean ice from below has been pushed upward and frozen in place. One hemisphere is heavily cratered and ancient, while the other is smoother, resurfaced by past geological activity. This contrast tells a story of a world that was once far more dynamic, shaped by the tidal forces of Saturn and the gravitational influence of its neighbor, Enceladus. Beneath its crust, scientists discovered hints of a subsurface ocean, locked beneath dozens of kilometers of ice. In the era of human expansion, Dione became a waypoint for crews traveling between Saturn's inner and outer moons. Small research stations and mining operations dotted its surface, taking advantage of its stable orbit and rich deposits of frozen water. Its fractured plains also made it an outdoor laboratory for studying the long-term effects of tectonic stress on icy worlds. From orbit, Dione appears calm and timeless, yet every ridge and fracture hints at a past full of movement, an ancient moon still holding secrets deep below its frozen shell. Approaching Rhea, Saturn's second largest moon, a quiet giant of ice and rock. Its surface is bright and heavily cratered, a frozen archive of impacts stretching back billions of years. From here you can see vast regions covered in faint, wispy streaks, once thought to be surface deposits, later revealed as immense ice cliffs created by ancient tectonic fractures. Rhea is a world of extremes. Half of its face is dominated by craters so old they've softened from endless micrometeorite impacts, while the other half is etched with younger, sharper features. Like many of Saturn's moons, it likely hides a subsurface ocean, though one buried deep beneath a thick, unbroken crust. For humanity, Rhea's value was strategic. Its size and stability made it a perfect site for orbital shipyards and refueling depots, while its distance from Saturn's intense radiation allowed for safer long-term habitation. Some of the earliest deep space freighters bound for Uranus and Neptune launched from Rhea's orbital docks. From orbit, Rhea appears calm, almost serene, a great frozen sentinel keeping watch on Saturn's outer system. Its silence hides an ancient resilience, the stillness of a moon that has survived untouched for eons. Approaching Titan, Saturn's largest moon, and one of the most fascinating worlds in Sol. Wrapped in a thick golden haze, Titan hides its surface from view, its nitrogen-rich atmosphere denser than Earth's. Beneath that shroud lies an alien landscape where rivers and lakes are not made of water, but of liquid methane and ethane, flowing under skies colder than minus 290 degrees Fahrenheit. For centuries, Titan was humanity's best analogue to early Earth, a place with weather, erosion, and complex chemistry, but without life as we knew it. Probes and landers revealed towering dunes of hydrocarbon sand, vast methane seas like Kraken Mare, and icy mountains crusted with organic frost. Beneath the frozen surface, scientists found evidence of a vast water ocean, kept liquid by tidal heating and perhaps harboring the ingredients for life. When humanity reached Titan in force, it became a center for both science and industry. Floating cities dotted its seas, mining hydrocarbons for fuel while research domes studied its chemistry. Its thick atmosphere and low gravity made it a dream for flight. Aircraft could glide for hours on a fraction of the energy needed on Earth. From orbit, Titan glows like a muted lantern, its haze swirling slowly in the upper winds. It is a place both familiar and alien, an echo of Earth's distant past and perhaps a preview of other habitable worlds yet to be found. Approaching Iapetus, Saturn's yin-yang moon, a world of striking contrast. One hemisphere is dark as coal, coated in material likely swept up from a more distant moon, while the other gleams bright white, made of pure, clean ice. The dividing line between these two faces is sharp and dramatic, making Iapetus one of the most visually distinct objects in the solar system. Its most mysterious feature is the equatorial ridge, a chain of mountains stretching along its center like a seam, rising up to 12 miles high. Whether formed by ancient tectonics, the collapse of a once spinning ring, or something else entirely, the ridge gives Iapetus a shape that looks almost manufactured when seen from orbit. Iapetus is far from Saturn compared to most of its moons, giving it a slow, stately orbit and a vantage point where the planet and its rings appear as a brilliant disk hanging in the black sky. For early human explorers, its remote location and unique terrain made it a perfect site for deep space observation stations and long-term science outposts. From here, Iapetus feels like two worlds fused into one, half light, half dark, with a mountainous spine running down its center. A silent, frozen enigma on the edge of Saturn's domain. Approaching Uranus, the tilted giant of the solar system. From here it appears as a smooth, pale cyan sphere, its colour born from methane in its upper atmosphere absorbing red light and scattering the blues. Unlike the other giants, Uranus spins on its side, its axis tilted a dramatic 98 degrees. This means it doesn't just have seasons, it has extreme ones, with each pole bathed in sunlight for decades, then plunged into darkness for just as long. Its atmosphere is calm compared to Jupiter's and Saturn's, with subtle cloud bands and occasional massive storms that erupt and fade without warning. Beneath the upper layers lies a hot, dense mix of water, ammonia, and methane ices, surrounding a small rocky core. This makes Uranus an ice giant, distinct from the gas giants it keeps company with. Its rings are dark and narrow, harder to see than Saturn's, but its moons are rich in variety, from Miranda's fractured cliffs to Titania's icy plains. In the early age of exploration, Uranus was a backwater, visited briefly by passing probes. Centuries later, orbital platforms and research colonies transformed it into a hub for mining rare ices and studying the outer solar system's unique chemistry. From this distance, Uranus glows softly against the black, serene yet strange, a planet that turns the rules of planetary behavior sideways, both literally and figuratively. Approaching Ariel, one of Uranus's brightest and most geologically complex moons. Its surface is a patchwork of smooth plains, deep canyons, and ridged valleys, all carved into brilliant water ice. Compared to many outer moons, Ariel looks young. Its low number of impact craters suggests that internal forces have reshaped it within the last few 100 million years. Ariel's most striking features are its chasmata, vast fault canyons that stretch for hundreds of miles, some with valley floors that appear to have been flooded by icy material from below. These signs of resurfacing hint at a once active world, possibly driven by tidal heating during periods when its orbit was more eccentric. In the era of human exploration, Ariel became a key scientific site for studying the link between icy geology and subsurface oceans. Small outposts were built at the edges of its great canyons, where cliffs of ice rise sharply above the plains, offering both shelter and panoramic views of Uranus hanging in the sky. From orbit, Ariel shines with a clean, almost reflective glow, serene from a distance, yet scarred by the tectonic upheavals of its past. It is a reminder that even far from the sun, worlds can be shaped by forces deep within. Approaching Umbriel, the darkest of Uranus's major moons, a world that seems to drink in the sunlight. Its surface is a deep charcoal grey, covered in ancient craters and showing little sign of geological renewal. Umbriel is old and quiet, a relic from the early solar system that has been largely unchanged for billions of years. One of its few bright features is Wonder Crater, a 250-mile wide impact basin with a mysterious ring of light-coloured material splashed across its floor, standing out starkly against the moon's otherwise shadowy surface. Aside from this pale mark, Umbriel is a land of darkness, likely coated with dust from Uranus's outer moons or space weathering from constant micrometeorite impacts. Because of its stability and lack of tectonic activity, Umbriel became a favoured site for deep space relay stations and archival data vaults in the age of exploration. Far from the disruptions of more active worlds, it offered a stable, cold environment for long-term preservation. From orbit, Umbriel is a quiet sentinel, dim and unassuming, but its very stillness makes it a time capsule of the solar system's distant past. Approaching Titania, the largest moon of Uranus, and a world that blends the scars of ancient impacts with signs of past internal upheaval. Its surface is a muted grey, crisscrossed by enormous canyons and fault lines that stretch for hundreds of miles. These great chasms, some as deep as Earth's Grand Canyon, were carved when Titania's interior expanded and the crust cracked apart. Craters dot the landscape, but many have been softened or cut by these younger geological features, hinting that Titania was once far more active. Scientists believe a subsurface ocean may still linger beneath its icy shell, warmed by residual heat from its formation and trace amounts of radioactive decay in its rocky core. In the era of human settlement, Titania became Uranus's primary hub for exploration and habitation. Its size provided stable ground for surface colonies, while its water ice and rock offered essential resources. Cities were built along the rims of its great canyons, their lights reflecting off towering ice cliffs under the dim glow of the distant sun. From orbit, Titania is both rugged and elegant. A moon where deep time is etched into every ridge and scar, yet where the promise of hidden oceans still whispers beneath the frozen crust. Approaching Oberon, the outermost and second largest moon of Uranus, a distant and rugged world steeped in shadows. Its surface is dark and heavily cratered, scarred by billions of years of impacts from the depths of the outer solar system. Towering mountains rise from its plains, some reaching nearly 4 miles high, their icy slopes catching the faint, cold light of the sun. Long, sinuous canyons cut across Oberon's surface, evidence of ancient tectonic forces that once fractured its crust. Some of these chasms appear to slice straight through craters, marking them as younger than much of the surrounding terrain. Like Titania, Oberon may hide a deep subsurface ocean, though if it exists, it lies far beneath a thick, unbroken shell of ice. Because of its remote orbit, Oberon became a quiet frontier outpost in the age of exploration, favoured by astronomers and long-haul traders seeking a place far from the bustle of inner-system traffic. Its thin exosphere and frigid temperatures kept it pristine, making it an ideal platform for deep space telescopes gazing beyond Sol. From orbit, Oberon is stark and solemn, a frozen sentinel standing guard at the edge of Uranus's domain, where the light is dim, the silence deep, and the stars seem just a little closer. Approaching Neptune, the farthest major planet from the Sun, and a deep blue giant whose discovery was a triumph of human mathematics. In the mid-19th century, astronomers noticed Uranus drifting slightly off its predicted course, as if tugged by an unseen force. Calculations pinpointed the location of the culprit, and telescopes soon revealed this distant, windy world. Its rich blue color comes from methane in its upper atmosphere, scattering sunlight into brilliant azure. But beneath that serene appearance lies chaos. Winds here are the fastest in the solar system, roaring at over 1,200 miles per hour. Storms the size of Earth appear and vanish in weeks, and high, thin clouds of methane ice race around the planet's equator. Neptune is an ice giant, composed mostly of water, ammonia, and methane above a rocky core. Its magnetic field is oddly tilted and offset, a sign of complex internal dynamics. And circling it is a system of faint, dark rings and a family of moons, dominated by Triton, a captured Kuiper Belt object that orbits in the opposite direction of Neptune's spin. For much of history, Neptune was visited only briefly by Voyager 2 in the 20th century. Centuries later, it became a waypoint for expeditions pushing into interstellar space, its orbit a last outpost before the darkness beyond. From here, it glows like a sapphire lantern in the black, a beacon at the edge of the Sun's domain. Approaching Triton, Neptune's largest moon and one of the most unusual worlds in the solar system. It moves against the flow, orbiting Neptune in a retrograde path, proof that it was likely captured long ago from the Kuiper belt. That capture came at a cost. Triton's once stable surface was shattered and reshaped as tidal forces tore through its interior. Today, it is a world of pale pink and white ice, with vast plains of frozen nitrogen and towering geysers that erupt from beneath the crust, venting plumes miles high into the thin atmosphere. These geysers are driven not by heat from the sun, but by the faint warmth of Neptune's tidal pull and possibly radioactive decay deep within. Triton is also one of the coldest places in the solar system, with temperatures dipping below minus 390 degrees Fahrenheit. Yet beneath its icy shell, evidence points to a hidden ocean, a possible refuge for life in one of the most remote corners of Sol. In the era of deep exploration, Triton became both a science frontier and a stepping stone to the Kuiper belt. Research domes clustered near its active geysers, studying their chemistry and searching for signs of biology. From orbit, Triton drifts silently around Neptune, a captured wanderer turned loyal companion, still holding the secrets of its ancient journey. Approaching Pluto, the former ninth planet, now recognized as the largest world in the Kuiper belt. Once thought to be a lonely, frozen outpost, Pluto revealed its true character in the 21st century when the New Horizons probe flew past, sending back images that astonished Earth. Instead of a dead, cratered rock, we found a world of glaciers, mountains, and ongoing geological change. Its most famous feature is the heart-shaped Umbriel Regio, a vast plain of nitrogen ice that slowly churns and flows like a frozen sea. Towering mountains of water ice rise nearby, their peaks frosted with methane snow. Dark, ancient terrains border these bright plains, telling a story of both violent impacts and slow surface renewal. Pluto's thin atmosphere of nitrogen, methane, and carbon monoxide expands and collapses with its long seasons, fed by ices sublimating under the weak sunlight. Its largest moon, Charon, is so big that the two worlds actually orbit a shared point in space, locked together in a cosmic dance. Charon's canyons, some deeper than the Grand Canyon, and its strange reddish polar cap, add to the system's allure. In the age of interplanetary travel, Pluto became a gateway to the Kuiper belt. Research stations and mining outposts now cling to its surface, and Charons supporting expeditions farther into the icy frontier. From here, the sun is just a bright star in the sky, and the rest of the galaxy stretches out ahead, marking the end of our cruise through Sol and the beginning of all that lies beyond.